with any field, you sort of have gradual improvements. And like I would say informatics is like the idea of data science is often kind of interchangeable with machine learning, but informatics is not just machine learning. There's a lot, the field is quite old. There's a lot, I would say it's more based in statistics. And I'd say now more and more, you're seeing more machine learning techniques like neural networks and all this. I mean, this classification is not really that complicated for machine learning, but the neural networks right now are coming more and more prominent, and there's a lot of interesting studies that are coming out of that. And it is lagging behind other fields, I would say, just because there's a lot of, like with all this data, you have to sort of tailor the machine learning techniques to the domain, like how the data looks like. That's really the hardest part, is like how do you kind of manipulate it to work with these technologies. And I've seen more and more now, there's a lot more like neural network papers that I'm seeing in like the big studies on biology. And I would say like within the next 10 years, like there's a lot that could happen. And a lot of it really comes, right now the topic is mostly on classifiers for cancers, but I'm sure there'll be other kind of issues that are going to be solving in the future.
Thank
you. That's a pretty good question. So I mean, like obviously, I mean, when I started doing this stuff, I was taking courses at Ryerson in computational biology, so I sort of got a primer in that regard. But now I'm actually exploring a lot of stuff on like Coursera. Even there's actually a bioinformatics like specialization, and I was going through it, and it's not that bad in terms of the topics. So that's definitely something you could try. Another thing is that what's nice about research is that all the data is public. Like if you publish a paper, you have to publish the data. So like when I was mentioning, like there's massive studies with 1,000 patients, you're not going to be able to do that on your laptop. But if you just have like 1 or 2 like patients or data sets, then that's something definitely you can crunch on your laptop. So I guess you could start by looking at some pipelines, like for mutation analysis, and see there's like so many resources online. So you just get some DNA data, go through the pipeline and see how it works at every step. You can do the same thing for RNA. And again, there's a ton of resources. So you just start with one data set, go through the steps, and in every step ask, why am I doing this? What is happening? And yeah, exactly. So that's kind of my recommendation, but I always find it personally that the best way to learn something is to have a project in it and a deadline. So, which is not always the case if you're trying to self-learn, but I guess try to set a deadline for yourself and some sort of goals and go from there. So I guess maybe if there could be a resource after this talk that you guys can access, because I can't really say it off the top of my head, but I know there's like so NCBI, there is a whole repository. There's like EGA repositories, but it's kind of better to basically look at a paper that does genomics and look at the data they used, and then it will point you to the right repository. So that like for me, if I'm looking for data, that's usually how I would start. But yeah, it like in terms of just some easier resources, like you could try that course I was talking about, Coursera, and see they probably have data sets if you want to go through it. And then if you're like getting onto the more high level stuff, then you would actually need to start reading like a paper about like breast cancer or something and see the methods they use and where the data is stored. So that's kind of would be my suggestion. I guess I don't really know off the top of my head like some really accessible, easy resources for it. I'm sure there is though, but we might have to look around a bit. Well, I mean, interesting thing is when I started my biology degree, I was like on the pre-med route. I did want to go into medical school, but so interestingly, like, and it didn't make sense to me at the time, but in one of the first year courses I had to take was programming. And, like looking back, I was just like, first I was like kind of scared of taking programming, but then as soon as I started taking it, I'm just like, wow, this is pretty cool. So that kind of started my seed for my interest, and where I sort of segued into like the biomedical engineering lab, where I was doing a lot of like programming and image analysis. So in the beginning, I wanted to become a doctor, but as I'm doing more and more on this research, in the back of my head, I'm just like, nah, I can't deal with people. I can deal with data. So, so I decided to just to stay within this field. And how I ended up in this lab, studying medulloblastoma, it was actually, it's not something like too profound. Like where I was working, the biomedical engineering lab I was working with before, like he knew this professor, and I wanted to do something that's less like engineering and more biology. So he's just like, yeah, like want to talk to him, see if you like what he's doing, and I did. So I mean, it sort of brings to light that you got to like talk to your professors and kind of don't be afraid to network, and don't be afraid to ask to like your current like research lab if you know anyone else that's doing research that's more interest to you, because they might help you out. So that's kind of where I ended up now, being a bioinformatician. But what happens next, I guess we'll see. Like, just certainly, right now I'm staying in the lab, but we'll see what happens. I guess I can't really do anything now because of the COVID. There's not much jobs anyway, but I'm definitely secure at SICKID.
That's amazing. Yeah, you definitely came full circle. You never know what's going to happen when you take an elective that's out of your comfort zone, right?
I mean, so what's interesting is like data. So a lot of these data algorithms, like random foresting, I was talking about, all this classification stuff, they're kind of domain independent. Like you could use it for anything. Like we were using it for methylation assays, but you could use the same thing to look at different groups of customers. You're trying to classify different customers, or you're trying to like classify mail spam or whatnot. So it's really kind of much of the same thing. Like I'm pretty confident I can sort of segue into like marketing and have all the techniques under my belt to. Only thing I'll need to study is the actual domain, like of what kind of questions are relevant in that field. But in terms of a person going into this, like I don't know if a person's interested in data science. I don't know if for studying biology first, it will be the most wise choice if you're just interested in data science, because there's probably a lot more like lucrative fields than biology that you can look into. I would more like focus on more the data science aspect, get the method, the theory down, really understand it, and then at some point you can start kind of looking into a domain, like in my case biology, or your case marketing or business. But again, like there's many different paths you can take to be a data scientist. Like I can't say there's one right way.
And
in terms of languages, like right off the bat, like whether it's a good thing or a bad thing, R seems to be the language in biology. So just using RStudio and R, and knowing, at least in my domain, you have to know how to different annotation sets for genes work. There's a lot of like SQL stuff. Unfortunately, it's behind the scenes in the code, so you don't have to worry about it too much. What else kind of tools? Like you definitely have to know like Python and Jupyter, because it's kind of right now Python's becoming the language for biology, and probably it's a good thing. I like that fact because it's much easier to read that language than R. But I don't know, like it's hard to say tools because like there's like you need the right tool for the job that you're interested in. Like I can't just like give you all the tools that I've ever used. Like it's really just it depends on the question you want to ask.
About software tools, I mean software tools that used for like statistical analysis or like big data analysis, just breaking down data into like smaller subsets. So software.
So I wouldn't say it's like it's like more like in R. I'm just basically doing that stuff in R. Like there's packages and libraries you can find. Everything is basically a matrix or a list, so you can just use like the regular programming techniques to move, stratify patients around. Because like in the end, like every single data point is represents. You can think of it as a matrix, like where you have a gene versus patient. So you could use like basic matrix operations to sort of move and manipulate the data. There's no like software suite or anything. It's all just like the standard native like packages in R and Python as well.
Got it. Thank you.